Hi, I'm Bharat Podal, PhD student at Birmingham City University. Today I'll be talking about our work, Boise, a multimodal inclusive environment that allows users with physical impairments to perform coding activities. This is a joint work conducted with Dr. Chris Creed, Dr. Mighty Frutos, and Dr. Ian Williams. This short presentation will discuss the background of the research, our developed prototype called Boise, and a short demo of Boise. This will also cover two studies, which we conducted with both disabled and non-disabled users. Finally, this presentation will talk about the contribution of our study. Programming involves multiple activities, which includes designing, writing code, debugging, etc. It heavily relies on using traditional input methods such as keyboard and mouse, which can be challenging for people with physical impairments. Assistive tools such as eye gaze tracker, speech recognizer, hand gestures are becoming popular and are being used as alternative input device. In terms of software industry, gaze and speech have been used independently to support people in development work. Speech-based coding tools such as Talon Voice, Voice Code are being widely used and presenting new opportunities for programmers with physical impairments by reducing the dependency on traditional input devices. However, these tools are primarily targeted for experienced users and have been rarely evaluated with physically impaired users. Similarly, tools like IDE, iNav, and CodeGazer have been developed to explore the use of gaze as pointing device for navigation purposes in coding environment. A number of research have suggested that the combination of gaze and voice can be beneficial and can provide more effective method of interaction as it addresses the limitation of each modality. Gaze interaction can address some of the misrecognition issue of speech, while speech input can help to overcome the issues of small target selection issues of eye gaze. Research have been carried out to explore the combination of voice and gaze in non-programming fields such as controlling desktop application, word processor, web browser, creative software. However, no prior work have been conducted to use speech and gaze interaction in coding environment. To address the lack of research exploring the potential of multimodal interaction approach and to assist coding activities for disabled users, we developed a code editor called Voice that can be operated using the combination of gaze, speech, and mechanical switches. The system uses voice input for verbal command such as selecting, navigating, and removing code as well as for dictating longer form of non-coding text such as comments. Gauge is used to provide a more controlled approach to write code via an on-screen keyboard. To address issue with slow typing speed, we integrated Emit code that allows user to write HTML CSS code via a shorthand notation. Meanwhile, mechanical switches are used for performing selection and triggering action. The prototype provides fluid design with a visual feedback of the spoken commands as well as selected letters. We'll go through the demonstration of the prototype. Open keyboard. Delete selected. Type welcome to my web page. End of line. New line. Go to 9. Type, I have more than 10 years of experience in photography. Left 6. Delete selected. Type 5. Delete line 1. Delete line 8 to 14. Open CSS. An evaluation was conducted with 29 non-disabled participants to investigate the feasibility of multimodal interaction in a coding environment. Through this evaluation, we want to evaluate if participants will be able to use gaze to type, voice to control the interface, and operate switch for selection and triggering the actions. 64 tasks including deleting, writing, selecting, and editing HTML and CSS codes were used. All participants completed the tasks and Voici received the usability score of 68.1, which can be labeled as OK. The prototype received positive feedback and majority of participants found the prototype to be useful. Based on the feedback, some updates were made to the system, including moving the cursor to the center of the line and moving the cursor to X position left and right, etc. Voici was evaluated with 5 physically impaired developers to explore their experience in writing HTML and CSS code using a real-world scenario. Voici received an average usability score of 74, which can be labeled as good and usable. All the participants were able to utilize the feature within Voici to write code. Majority of participants reported that Voici was better than their existing coding tool and provided positive comment about multimodal interaction approach. Previous research have independently explored the potential of gaze in speech. This study presents a new system that integrates this method of interaction to provide more efficient approach of coding. The result from 2 user studies were positive and demonstrated the feasibility of combining gaze, speech, and mechanical switch interaction for supporting development work. The majority of participants from the first study found coding by a multimodal input control to be an intuitive and simple. Physically impaired developers from the second study also made similar positive comment with several stating that this approach provided advantage over their existing assistive method of interaction. This prototype is loosely coupled and can be extended to include more coding features such as navigation debugging in near future. We are grateful to Microsoft for supporting this project through an AI for Accessibility grant. We also thank London RSI Support Centre for supporting the recruitment of physically impaired developers. Thank you very much for your time.